Okay, we'll go ahead and get started. This just seems odd, not having my microphone. I think it's scheduled to show up tomorrow. But I just wanted to point out number one on this paper that just handed back. Everyone did it right. It was, I don't want to say it was last year's group that pointed this out. And I just looked at it and said, you're right. Okay, and that is someone said they can go, I don't know who said that, but we'll point that out so we can make sure that we're all on the same page here. To my knowledge, that's enough. Well, that's a hydrogen bomb. I'm getting the impression that you probably will not write formulas like this out very often. So, and maybe it's worth our time to take a look at what maybe this really would look like. Well, for the time being, someone had mentioned you can go either way. So if we named it as 4-secondary butyl 2-methylnonane, that's right. But could we name that something else? And the answer is yes. We could still name it a nonane compound, but we just would not start here. Start down here at the bottom, but on the other side. But the only thing that, since this is just naming compounds rather than giving isomers, we actually could call this an isomer of what type. If we say X marks the spot here for going that way, what type of derivative is that? It's an isobutyl group, okay? So then if our parent chain was to go left, up, and over, of course we say X marks the spot here. So then what, pretty simple, we've got just a simple derivative here, a methyl group. Then the tricky part about that is, all right, well, not really, just on account of, we just have an I and an M, because we use this for alphabetizing, okay? Even if that was a secondary butyl, of course, tertiary butyl, you would skip past that letter, but I we do use. So if we were going to go up and over like this, what number of carbon is that derivative on? Okay, so it would be 4. That probably all blends in together. Okay, we've got 4 dash isobutyl dash 2 dash, I didn't leave enough room.
It should be 3.
I did that to see if we were paying attention. Okay. Yeah. We can also just, I had my fingers crossed, we were lying. I was thinking it was that methyl group there. I don't know if you buy that or not, but it's for sale if you buy it. Okay. But yes, that would be an isomer of that. But can you think of a reason why we would not name this compound this? This might exist. Everything about this is correct. But why may we not call or choose not to call this compound that? Yes, because your other ways have smaller numbers. Here we have 4 and 3. If we go this way, we've got 2 and 4. Okay. And I understand it's not a competition of adding those together. It's just when you have a 2 as opposed to a 3, that's what you're going to start with, rather than a methyl group there. Because I don't know how far away I can get from this computer where it doesn't pick up the sound. Otherwise, it probably sounds like I'm at home if I don't want to get in trouble. I just start talking. What? Your mom? No, I'm not mumbling. You just can't hear. That usually don't work. Anyway, so tomorrow we want to focus in on, there wouldn't be anything really this complex. I mean, you're not wrong, okay? But if it was naming, and technically, you really can't count that wrong either, right? But we still want to have the same type of pattern. Okay, that's that's what we would have tomorrow, and reactions. There's not a lot for the reactions. Oh no, nothing this complex. No, no, and I don't think that there should be either, unless we go back to what we said earlier. You can do it. So that'll be our goal. If one of you students we just happen to catch that have to parallel park, we'll go out there and we'll cheer you on. Although I don't know if we'll be able to see that. Okay, we'll continue here in just a moment. Well, yeah. I just want to spend a little bit of time. Don't try to make this more difficult. It's gonna look difficult because you have not seen this before. Okay. Well, we have. We just haven't spent any time on it. Okay. So if if we did something like that, okay, we'll do that. See, I got to look myself. And this isn't on your evaluation tomorrow, no. But if it's something that you think could be useful, then maybe you'd want to write it down. But that's entirely up to you. Again, I'm a firm believer that once you latch onto a concept and understand it, I don't think you'll ever forget it. It's just that you might need a refresher. I mean, I don't want to say reteaching either, but I think you get the idea. And the reasoning we gave is we do this all the time when it comes to ring structures. Okay. So does anyone want to take a guess? Well, not guess, but what do they think this would possibly be? You are correct, and I didn't know we'd come up with it that fast. Okay. You'd probably rather draw this heptane than cycloheptane, right? And just so we're all on the same page, it's easy to forget. And when I first saw this, I thought, well, is that a hydrogen atom branching off of there? Of course, the answer is no. So we say heptane, that would be right. 1, 2, 3, 4, 5, 6, and then 1 on the end. Okay. Then one of the things that could happen with that, okay, let's just go ahead and do the same thing down here. Okay. What about if you saw something like that and then that? Now what might, it's still heptane, so we can go ahead and draw that in. Okay, so we know that's heptane. Yes, yes they are. Okay. And it's just under a presumption that, and we say that that's correct. It's just under this same presumption that, notice we don't write this. I mean, yes, you can. Okay, it's just under the presumption that all these dashes are hydrogen atoms, unless you say something else, which then we'd be changing the organic family. Okay, so then that's something that you would have to write on there. Okay, so we take this same logic that the presumption here, not assumption, I don't like using that word. The presumption here is there's nothing on there, that these are hydrogen atoms, and then that the presumption here is if you have a branch coming off of there, that you'd have something like that. The same presumption here is what we'd have up there. So now we have this heptane molecule, which has methyl groups on which carbons? 2 and 4, right? No. Yes, 2 and 4. Okay. So then we can't go this way. 1, 2, 3, 4, 5, 6. So it's 2, 4 dash dimethyl heptane. To me, we are so used to this, and as long as we know what this is here, we can make that transition pretty quick. Of course, then up and down. Okay, so these are the same compounds. Okay.
So that wouldn't be.
This one here?
Would that, could you use that as an isomer?
No, because it's the same thing. Okay. So I don't know if that would be the case for up at SDSU now, and you might not know. Okay.
Like, what one are you?
This down here. Yeah, I couldn't tell you for sure either. And I don't. The last thing that I want to mention is for our purposes, okay, we term these as just regular isomers. And this would be another isomer of what we just had. We had 2, 4 dimethylheptane. We can have 2, 3. You can also have 2, what would that be then? 2, 2. Okay. So those are, for our purposes, we just want to say are regular isomers of one another, because it gets to be a little more tricky when you start throwing what I like to say is constitutional isomers. We just mention what they are, so that again, once you see that, I remember talking about that. Okay, so what we mean is this right here. Okay. And once we put this up on the board and say, oh, well, that makes sense. Okay. All right. So, and we know how to name this. What would we call that? Cyclobutane. Excuse me. And what is the formula for that cyclobutane? C4, I like that number.
C4H8.
C4H8, okay? That's where it gets to be tricky, okay? Because now, if we did something like this, and we haven't covered this yet, but maybe from prior knowledge, what would that compound be called? It's butene, because the same pattern follows. You've got this, okay? We know it's not a ring structure, but the difference we see, what's the formula between the two? What would this, remember we counted out the carbons here, what would happen if we count out the carbons for that? And hydrogens. Yeah, you would receive C4H8, okay? So you have the same formula here, but you have two totally different structures. So for our purposes, if you cross organic families, we're going to refer to them as constitutional isomers. If we say isomers, we're going back to this, okay? But constitutional isomers, you would not see until your exam. I just didn't switch it on Friday, on part 2, okay? And I think that would be an applicable place to put it if we decide to. So is there any questions over this? Okay. And again, when we see an alkane, everything's single bonded. When you say an alkene, then we know there has to be a double bond, even though you have the same formula between the two. But again, you're crossing organic families. Okay? Then we had just mentioned when it comes to reactions, what's probably the number one aspect that we want you to be recognizing. So someone give me an alkane. Did I hear 5? Pentane.
Yeah.
Okay. Then how about a halogen? Okay. Probably the most common one, not the most electronegative, but probably one of the more common ones. Okay. So then probably the first thing to look at is that is no reaction. But it doesn't say why there's no reaction. Okay, there's nothing located here. And this will be probably more common next chapter. It gets to be a little more content where when something like this happens, then I'll just do something like that. I'm just circling saying, hey, there's nothing there. That can't react. Okay. And the reason for that is these bonds between these carbon and hydrogens, this compound is just too stable. It can't do anything without a little boost. And that's what the catalyst would do. So we'll just keep it simple. Heat. Then finally, how many products do you have? You get 2. And all you're doing is just taking a chlorine anywhere on the end. And then what's your other product? Now, and that's not to say that, well, why not put it on the third? Well, you probably could, but for our purposes here, we just want you to be able to recognize that something like this happens. And there's a reason for this, because when we get to next chapter, not only do you have to recognize that you get 2 products, but you also have to label them. Okay, here we don't label. You could say chloropentane and 2-chloropentane, and that's fine. But should something like this happen next chapter, you would probably name these and then and see if we remember this probably a couple weeks from now. This is not accurate for this chapter, but this would be accurate for next chapter. You have to, this isn't correct for this. But next chapter, you'd have to label this as the major product and then this one as the minor, which doesn't mean anything to you right now. Okay, isomers and reactions. Front row, good. Middle row, and back row. All right, so we'll catch up to you next time.